Kubernetes production environment, like any other production environment, relies on perimeter firewalls. Although those firewalls are very helpful in protecting against large-scale boot attacks, they are not by any means foolproof, especially considering that Kubernetes itself, when you go through the deep auth installation, doesn't provide any network security at all, which means that if a hacker, through, let's say, a piece of malicious code, gains access to a pod or a host, he or she can easily start attacking other pods and hosts, and eventually will attack and gain control of the control plane itself. So we need to come up with a strategy that provides security, self-sufficiency. And this is especially true if you're planning to deploy your Kubernetes environment on a third-party cloud, because that cloud itself may come under attack. So we need to come up with zero trust policy. In the past, we provide a couple of methods of protecting our Kubernetes environment, and I'll provide a link up here. One of them was using Kubernetes on network policy, and the other one was using Calico's network policy. Calico, in my opinion, provides far superior security enhancements compared to Kubernetes itself. However, if you are using Istio, then you're in luck, because Istio provides great security features. And that is the topic of our discussion for this video. As far as the agenda is concerned, we are going to talk about a quick overview of Istio Service Mesh. I provided an intro to Istio Service Mesh. If you haven't watched it, I provide, again, a link up here. You can go ahead and watch that. Then we will provide an overview of Istio security, what is the architecture of Istio security. Then we talk about some of the things that Istio security features that Istio is using to protect our environment. One of the most important one is a mutual TLS or mTLS, that is for authenticating and protecting and authorization of the services. And also we will talk about JSON Web Token or JWS, and JWS is used to authenticate the clients coming from outside the cluster. We'll also discuss Istio certificate management, how certificates are created and distributed to our workloads. And finally, we put to test into practice what we learned in this topic before that, to provide some demo of features that Istio provides. This is an intro course, and of course we cannot cover every features of Istio, but I do hope that it provides you with enough knowledge and confidence to start looking at Istio security on your own. Also, if you are interested in more security topics, especially related to Istio, let me know, and I'll try to provide other features, other videos in the future. In the previous episode, we discussed what a service mesh is. A service mesh is a dedicated infrastructure layer that you can add to your application. It allows you to transparently add capabilities like observability, traffic management, and security without adding them to your own code. So Istio is one implementation of a service mesh. We also discussed how to install Istio, download that, and then run this command to install it. And the profile, the set profile, that is, you specify what features of Istio you want to install in your environment. A demo installs everything, all the features of Istio. So once Istio is deployed, it creates what is known as Istio control plane, basically also known as Istio-D. So it's a process that is installed. It has a number of components, such as Pilot, which provides service discovery for the Envoy sidecars. We'll talk about envoys in just a bit. But whenever a service is created, a new service created, pilot will know about that, and then we'll send that information to the proxy. Citadel, it enables service and end user authentication management. So anything to do with security is managed by Citadel. And this is our concentration for this demo, for this video, is talk about security here. And Galley is configuration management. So as you create policies for authentication, authorization, and network policies, all of those are validated and created actually through a Galley, and those will be sent to other components such as the proxy. And Istio works by namespace. So you have to specify what namespace is will be managed by Istio, and the thing that you need to pass in for that namespace is create a label, and the label should be Istio-injection is equal to enable. So once you do that, then Istio will manage all the services. So let's say we deploy a new application, and then the pod will be deployed from a repository such as a Docker. And once that deployed, the first thing that Istio does is actually inject a new sidecar. So this is another container that is injected into the pod. So inside pod now we have our application, and then there's also the proxy. So this NV proxy, in combination with the control plane, provides services such as load balancing, circuit breaker, health checks, fault injection, metrics, and so on. So we talked about a lot of those in the last session. This session, we'll talk about mostly the last part, which is enforcing security policies that we deploy to our mesh. Now let's take a look at some Istio security components. First one is certificate authority, or CA, for key and certificate management. Services use certificates to authenticate and also enforce authorizations policies. The configuration API server distributes to the proxies authentication and authorization policies. So like everything else, in Kubernetes, we can define authentication and authorization policies through YAML, and then we'll go through the syntax when we get to the demos. Secure naming information, basically what it means is identity to service access authorization mapping. So every service that is deployed, it has an identity. And then this mapping ensures through these policies that what service account that each service is running is allowed to do what, to access what other services. So that's called secure naming in Istio jargon. Envoy proxies work as policy enforcement, as we mentioned before, and that is they implement the security and the authentication and authorization policy that are enforced through the Envoy proxies. It also installs a set of extensions to Envoy proxy to manage telemetry and auditing information. Now let's take a look at high-level Istio security architecture. So this big box here with broken lines, that is the Istio, that represents the Istio mesh, which means that anything inside this box is managed by Istio. So we are really talking about a particular namespace which we have identified to be managed by Istio. So this green arrows, they represent the traffic that flows through the mesh. This purple lines and arrows that represents the traffic between the Istio control plane and the proxies. So if you recall, proxies are the enforcers of our policies. When we define a network or security policies, those policies are flown to these proxies, and they actually enforce our desired state for communication and security. This star represents a certificate. So because we use mTLS or Mutual TLS, the authentication is based on certificates. So we'll go over mTLS in details right after this. So let's go ahead and kind of walk through what happens when the user wants to get into or call, let's say, a web service, a web application inside our mesh. What we could do is, by default, it is not enabled, but we could enable authentication for the user. So this user, in order to be able to come into our mesh and use our resources, needs to be authenticated. So the authentication happens through what's called JSON Web Token. So any store that that supports JWT or JSON Web Token can be used for our authentication. So Istio does not by itself authenticate the end user. So we need to provide a method for that. So we can define any store that provides JWT authentication and authorization, and then we can leverage that inside our mesh. During the demo, I'll show you how to set that up and how to kind of enforce this authentication. But for now, just realize that we can, if we choose to, we can force the user to be authenticated before getting into our application. So when the request comes in, once that authentication is passed, then it comes to the service. And then that service, then, if we choose so, we can say, let's say we have 10 users, but only a few of them are able to access this particular application. So if you are authenticated, may not be enough, we can actually add policies that say only Joe and Nicole among the 10 users that we define for our application, only those two can access the service or this application. So again, we can lock down based on the user, and the user's identity comes from the certificate of the user that presents during the authentication process. And then the service A wants to talk to service B. The first thing I realize is that they cannot directly talk to each other. They have to go through the proxies. Again, those proxies enforce our policies. So the authentication between these two, which actually happens between the proxies, is called PeerAuthentication. And that is used service to service, and the PeerAuthentication uses mTLS or Mutual TLS for authentication purpose. By default, Istio enables mTLS authentication between services. So if we don't declare anything, any policies by default, these services that are within the mesh, they already talk to each other and they use mTLS. However, if we have a service from outside that tries to call into the service, in one of the services, by default, it's allowed, even though the services amongst themselves use mTLS, but by default, if we don't specify any policy, they can talk through HTTP rather than HTTPS. So, but again, we can enforce that through a policy that all communication, regardless of where they're coming from, they need to have to use mTLS. So, and we can show you that during the demos. Principals are important components of Istio, and those are basically the service account, depending on what component we are talking about. The service account that these services are running on, these are the principals for the services. And for the end user, the name on the certificate is the principal. And those principals we can use again for authorization. Again, we can say that this service is not allowed to talk to the service, and the means by which we can enforce that is to use the name of the service account that is using it, or this is allowed. So again, those are really great benefits of Istio, is that you can lock down very granular access to a specific service or a group of services to a specific user or group of users, that what resources can be used within the mesh. So as we just saw, mTLS is a big part of Istio security, and all the authentication happening among services in TLS, they are all through mTLS. So again, mTLS stands for Mutual TLS, and TLS stands for Transport Layer Security. So TLS, it used to be called SSL. So you might have heard of SSL. It's the same thing. It's just a newer versions of SSL. So in order to set up an mTLS session, basically, the first thing that the services will need to do is they need to have valid certificates. So those certificates are issued by what is called Certificate Authority, or CA. And there are many CAs out there, and each machine has kind of a store that stores all the trusted certificates, CA certificates, or issuer of the certificate. So any certificate that is issued by one of these certificate authorities, then on both sides they are accepted and trusted. So the first thing that when the client wants to talk to the service, before even requesting the resources, they have to go through what is called a TLS handshake. And basically that is literally is called client hello, and this is a printout of what happens and what information is being sent from across the wire between these two machines. So they, for instance, the client says, I support TLS version 1.2, and then these are the cipher or encryption algorithms that I support. These are the compression method that I support. It also generates a random key, and that random key is sent to the server. So now the server has a random key that the client sent, and we will go through that, and then these are other elements are added to these collections, and then after that they generate a symmetric key that then encrypt and decrypt messages with it. So then the server does the same thing. It generates a random key, and then it also tells the client what version of, for instance, TLS support, compression, algorithms, and so on. So those are also sent to the client. And at each point, if the client or the server, either of them do not agree, for instance, on the algorithms libraries, then the TLS session actually ends there. It doesn't go any further. So now at this point, the client and server have the random keys that was generated. The server also then at this point sends its certificate to the client to be validated. And the certificate, again, is validated against the trusted root certificate in the store. And each certificate has quality or attributes such as server's public key, serial number, validity period, if its certificate is valid or not, and when it expires, server's domain name, issuer's domain name, and issuer's digital signature. And then the client validates some key information. First of all, make sure that this certificate has not expired. If the certificate expired, then the communication ends right there. It also checks the issuer's domain name on the certificate against the issuer's domain name of the trusted CA that it has in store. Again, if they don't match, then that certificate is not accepted. The issuer's public, it uses the issuer's public key to validate the digital signature on the certificate. So only this CA, which uses its private key to sign the certificate, can be validated with the public key. So if they don't match, again, this certificate seems fake, and the communication, again, ends right there. And the client does the same thing. It sends its certificate now to the server, and then it goes through the same process of validating the date, signature, and the domain name. And then at this point, once that's done, then the client generates what is called pre-master key, and that sends, and again, along this information will be used to generate encryption key. So that generated, that pre-master key is generated, and it is signed with the public key of the certificate that it got from the server. So this is called asymmetric encryption because it's using the public key of the server to encrypt the message. So that sends that pre-master key to the server, and then server uses its private key to decrypt the message. And then now this is the decrypted message that the client sends. So at this point, we have this information. So this information, the client random key, the server random key, the pre-master key on both sides, they use one of the agreed upon algorithm or the encryption algorithms, and then each party independently generates 4 keys. The server encryption key is used to encrypt and decrypt messages that the server sends. So again, both parties have this key. And then the client encryption, the same thing. Client uses that to encrypt messages. The client MAC key, so MAC stands for message authentication code. Basically that validates that the signature that a message is alleged to come from the client is actually true. So that's how that the signature can be verified. The same thing for the server. So server uses that to validate, to create signatures and also validate signature that it sends and receives. So again, those are shared between these two. So let's say at this point, the client wants to consume a service. So the first thing that it does, it encrypts the message with its key. So the client uses the client encryption key to encrypt the message. Also, it uses the client MAC key to sign the message. And then the message is sent across the wire to the server, and server goes the reverse. It uses the client encryption key to decrypt the message. It also uses the client MAC key to ensure that the signature that this message has not been tampered with and is actually coming from the client. And then this sends this request, let's say, to a method called hello world. So when this is the request, comes through the session unencrypted, and now it calls into this, for instance, it's called a function called hello world in this case, and then the response is created. So that response, again, it goes through the same process of encryption. So it uses server encryption key, it uses server's MAC key to sign it, and this message then sends across the wire, and again, the client uses the server encryption key, validates with the server MAC key, and that is how the message is received. So from this point on, as long as they are in the same session, then they use those keys to encrypt and decrypt message because the trust has been established. But these are not permanent. Once the session ends, then if the client makes another call, then they have to go through the same process as described. For end-user authentication and authorization, Istio supports JWT, which stands for JSON Web Token. It's a method of authenticating a user and issuing that user a token and that token can be used as the proof of authentication and be sent to the services that he or she wants to consume. So let's assume that we have a Kubernetes environment set up here, and it is configured to use Istio. And then we have a number of app components here. We have a UI that we want to open up to the outside world. And that UI also calls into a number of services, backend services. And let's assume that we want to make this secure end-to-end. As we already talked about it, all the components that reside inside Istio service mesh, they're already secure because they use mTLS, Mutual TLS, to authenticate and authorize each other. Now, we want to also require that the end user to authenticate themselves. So we need to create a new policy that will require the client that will call into this UI to be authenticated. How to do that, we will discuss the actual code and YAML that is used to generate this kind of policies when we get to the demos. So for now, let's say we create that requirement, that policy, and now the client will need to use this JWT server to authenticate. So any authorization server, JWT servers can be used for this for authentication and authorization purposes, as long as it is configured inside Kubernetes to be used, so that is be trusted, and the client also trusts that. So as long as this to trust this service or server, then we can use that as our authentication server and authorization server. And inside a JWT server, there are a number of functions that it provides. First of all, it should be able to authenticate the client. And once the client is authenticated, then the server will generate a token, which is in the form of JSON, and that's where the JWT comes from. The JSON Web Token is a token which is in JSON, created in JSON. Also, the server will provide a way to authenticate or to validate the tokens that is sent to the server. So the client will send that token to the server, and the server will then forward that again to JWT to servers to validate, to make sure that that token is valid, is legit, it hasn't been tampered with. Okay, let's go through the process of how it actually works. So the client, first of all, contacts the JWT server, and then it uses obviously HTTPS, and then they log in the user ID and password. And once the user is authenticated, then JWT server will start creating a token. A token has a number of sections. The first section is header, which basically specifies what algorithm it uses to generate the key and sign the key. So what algorithm it used to create the signature for. Then it has a payload, and payload basically consists of the claims for the client. In this case, let's say we have issuer name, which is the name of the server, the name of the user, which has been authenticated, and the date that this token is expired. So usually these tokens have very short span of life, and they expire maybe within minutes. The token also, very importantly, has a signature, and that signature is a calculated field. And the way it's calculated is it uses an algorithm that is specified in the header and then plugs in the base 64 URL encoded value of the whole header, plus then base 64 URL encoded of the whole payload. And last but not least, pass in the secret, which is a private key that only the server has, and then it generates the signature. Now this token is signed, and then it's sent back to the client. At this point, we are ready now, the client will be ready to call into the service and pass this token that's required, that acquired from the server. So let's say we put that token into a variable called token, and then now we can call the service. So as part of the header, that when we call the service, in the header, we'll also need to include the token. So the format is authorization : bearer and the value of the token, and the token that we just acquired from the authorization server, and then followed by the URL that we want to call inside our Kubernetes environment. So that is sent to the Kubernetes, and then Istio will validate that. So we'll send that token to the server, and the server reverse engineers that, because it's all base 64. It reverse engineers and regenerates the token that was issued earlier, and then starts to validate the token. First of all, it ensures that the date hasn't expired. And then the next thing that it does, it validates the signature because it has the private key that it generated the signature. So it ensures that it hasn't been tampered with, and this is its signature. So it remember, we use a function to generate the signature. So use the kind of reverse engineers that, using the private key and the header and the payload, and make sure that this exactly comes out as and that private key was used for. So that's how the token is validated, and once it's okay, then it informs the server that it's valid, and then the function or the method is called, and the result is back. So this is kind of a quick overview of JWT, how it works. So by now, we should know that certificates play an integral part of how Istio manages security, from the identity of components to authentication and authorization. So the question is how those certificates are generated and managed. So if you recall, Istio control plane has a component called Citadel, and Citadel manages everything related to security. And one of them is the certificate authority. So this is where the certificates actually are generated through Citadel. So let's go through the process of how it's actually been done. When we deploy a pod into the Kubernetes environment, then Istio also injects a container inside that pod. So now we have the original pod or container, which is our application. Istio also injects a new container, which contains within it an Istio agent that talks to Istio control plane and the envoy proxy. So Istio agent generates a CSR, which stands for certificate signing request. So anytime that we apply for a certificate, we need to generate the CSR, no matter where we are, and that's no exception within Istio as well. So that generates the CSR, which basically includes something, things such as common name, organization, and so on, and the name of the person, of the subject of the certificate. It also generates a public key, which will be part of that CSR, and also it generates a private key. And then it sends that CSR to Citadel, and then once it's validated, and it generates a certificate, and then Istio agent sends that certificate to the envoy proxy. And now this pod and envoy proxy have the certificate and the private key, and they can communicate to other components within the Istio environment. Time to perform some demos. So for this demos, we're going to use a Kubernetes cluster with a single server. So this server will play the master and also a worker node. And it already has a default namespace as when you create a new when you set up cluster, it automatically creates a default namespace. We will also create a namespace called books namespace to perform our demos. And then we'll configure that namespace to use Istio. And then Istio creates a default gateway that will allow users to come in and consume the resources inside the namespace. We'll also then install a simple application called Books, and it has a UI page which clients can come in and look at the books, look at the details, reviews, and ratings. And since this is under Istio now, Istio will deploy a sidecar which has an envoy proxy. And then as we saw, envoy proxy requests for a certificate for this pod. So now all these pods have certificates, and they use mTLS as they communicate among among themselves in this namespace. We will then deploy a simple application pod that in the default namespace. So I'll see how we look at scenarios as this pod tries to connect and consume services inside this namespace. We'll play with different security settings. And we'll also have some clients that will be calling into the application through the Istio gateways, and we'll look at authentication and authorization for them as well. So in this section, we're going to set up the environment that we just talked about. And I've set up created some variables that withhold the name of the pods and gateway addresses and so on. So let's go through the code. By the way, I provided the code, a link to this script, so you can do it, either follow along or do it on your own time. So first on line 50, we're going to create a new namespace called books. So let's go ahead and create that. And then we want to configure this new space to use Istio, and that is the command on line 52. kubectl label namespace books Istio-injection equal to enable. So this the key part is creating this label called Istio injection enable. So let's go ahead and run that. And now on line 54, we are going to create that sample applications that we just talked about in the previous slide. So let's go ahead and run that. That's created now. And on line 56, let's go ahead and verify the services that just was created as part of this deployment. kubectl get services minus n books. So we're looking at a books namespace. And these are you should be familiar to you. We just talked about that in the previous slide. Details, product page, ratings, and reviews. Okay, on line 59, you're going to open this service to the outside world. Now, this service is available from inside the cluster. However, in order to make that available to outside world, we need to create a new gateway and allow outside traffic. And that is on line 59. We talked about gateways and virtual services in the previous episode in the introduction to Istio. If you don't know what they are, please go ahead and review those. And then once we open the gateway, we need to construct a URL where the outside client can get into our service. So the first one is cluster IP. Although that is internal, ingress port number. So that gateway has an ingress port number and also ingress host. So that would be one of the servers, one of the servers that Kubernetes cluster that we have. So that sets the IP address to that. So basically, on line 66, gateway URL is equal to the combination of ingress host and ingress port number. So let's go ahead and do that. And then on line 68, so this will be the URL in order to get into the service from outside world. Let's go ahead and run that. So that's the gateway address and port number. Okay. Now we're going to quickly test this service coming from outside. So we're going to use the gateway URL, and then we're going to call the product page. Let's go ahead and do that. And then, because that's the whole page, we are not interested to show the whole URL. I just want to, or HTML, we just going to verify that this works or not. That's why we look for title in that page that comes back, which is going to display that, and that is the results. Okay, so far so good. Now let's go ahead and gather the ratings pod. So each one of those applications created a number of pods. We're going to put them in a variable for convenience so we can call them later. So that is for ratings. Next one would be product, the product. And then we get the details also. So, and I've gone through that before to how to get this information from using these commands. Please refer to previous presentations. And then we're also going to get the IP address of the detail pod. Okay. The last thing we want to do is create a new sample test application, like we said. So this test application will be from outside, will be from the default namespace, which I've already created that. So, but when you create it for the first time, it will download and install the service, that application. And then we're going to get the pod name, the test pod name also, we put it in a variable. And this new pod does not have curl, so it's going to, again, for convenience sake, we're going to install curl on that new test pod, and that's done. Okay, now so all we've done so far is we usually set up our environment, our test environment, and then next section we're going to actually apply new policies that represent some of the security features of Istio. So let's discuss the first policy that we're going to apply. Currently, all the services that are running inside the books namespace, they use mTLS and HTTPS. However, if a service from outside this namespace, for instance, this test application from the default namespace, it uses HTTP, it also allows. So we want to kind of close that loophole, and we want everything, all the connections, regardless of coming from inside this namespace, from outside, use mTLS. So we are back in Visual Studio Code to implement the policy that we just described. First, before doing that, we want to verify that without applying that rule, that policy, we are able to call from the test pod into any service that we would like without any mTLS or HTTPS. So on line 93, cube ctl exec minus IT. So we are going to sh into this pod, which is the test pod residing in the default namespace. We're going to call a service, the detail service, which is hosted inside our books namespace. So let's go ahead and run that. As you can see, that we get the result back, no problem. So now we want to apply the rule that any calls to these services that are hosted inside books namespace must be using mTLS, regardless of they are in that namespace or coming from outside. So let's take a look at the YAML file that we are going to apply. And it's pretty actually straightforward. Like any other Kubernetes object, you specify the API version, and the kind is PeerAuthentication. And metadata, and the metadata, you specify a name, and also specify what namespace this policy applies to. And under spec, we specify mTLS, and then mode strict. So all we have to do is just create this policy and set it to mode strict. So let's go ahead and execute this YAML, and that's done. Now let's go ahead and repeat that test that we did up here. So again, we're going to SH into test pod and execute the detailed service. Let's go ahead and run that. And this time we'll see that it fails. It basically says it's not allowed because now we upgraded, required the communication to be all mTLS. And one thing to note that from within the books namespace, when we call, let's say this is from the ratings pod, if we call the same service, the details, we don't have to specify HTTPS, we have to say HTTP, because if you recall, each pod has two containers. One is application and the other one is the envoy proxy. So the envoy proxy will upgrade the communication from HTTP to HTTPS and will take care of all the certificates and authentication and etc. So let's go ahead and run that. As you can see that no problem, we can call that service with HTTP from within the that namespace. So now we have set up strict mTLS authentication within the books namespace. However, there are times that maybe we want to relax this rule. For instance, we are migrating our applications to Istio, and maybe if this namespace is not quite ready to adhere to mTLS authentication. However, we have some legacy application that still need to access, for instance, the DTL. So we want to create an exceptions in this case. Let's say that this application or the applications outside this namespace be able to call into details. So we'll look at two policies. The first one is allow all traffic to all ports on this service, and the other one would be more prescriptive, and we only allow access to specific ports. So now let's see how we can give access to applications that cannot support mTLS. So in this case, we take a look at this policy. Again, we are talking about authentication, so that would be the kind of the PeerAuthentication. And again, the namespace is books. And then under selector, we will have to find what we're looking for. And under match labels, we are only really concerned about details. So any pod that has details match will be part of this selection. And under mTLS, we specify mode as permissive. So which means that this allows non-mTLS to be called into this server or to this pod. Okay, so let's go ahead and execute that on line 116. That's done. Now let's see on line 119 to see if we are allowed to call from test pod into that details pod. Let's go ahead and execute, and now we'll see that we are allowed to do so. However, on line 121, we're still not allowed to call any other services that adhere to strict mTLS authentication. So if you execute that, we'll see that we'll still get the access denied. Okay, right now, so test pod can call into any ports on the details pod, which may not be appropriate. So we want to restrict that to only be able to call to port 9080. So first, let's go ahead and delete the previous policy we just created on line 125. So we're going to delete that policy. And let's see now that we delete that policy, we want to verify that now the test pod is not allowed to call into details. So let's go ahead and try that, and I will see that it fails. Okay, now we are going to take a look at the policy that will allow access to port 9080. So again, the kind is PeerAuthentication. Again, namespace the same. Selector is still the same. We are only concerned about the details part. And then mTLS, we say specify that mode is strict. So we are saying that we're still requiring strict mTLS. However, we provide an exception and the port level mTLS, and the port number is 9080. And here we say port is, the mode is permissive, which means that now this pod is allowed non-mTLS traffic to its port 9080. So let's go ahead and execute that. Now let's try again and see from test pod if we are allowed to call into the details, execute that, and we'll see that now this time it succeeds. So far we've been talking about mTLS authentication exclusively. Now let's switch gears and talk about authorization as far as services are concerned. Let's say in this scenario, we only want that the product page to be able to call details. So we want to disallow traffic from reviews or from ratings to the details. So we want policy set up to basically strictly grant access to details only from the product page. So first verify that we can call into details from any other pods in the books namespace. So from here on line 138, we SSH into the ratings pod, and we're going to call the details and see if that succeeds. And it does succeed because we don't really have any policy right now that this allows us. So let's go ahead and take a look at the policy that will change that. So the kind is AuthorizationPolicy, and then namespace still books. And then under selected, as usual, we need to specify what pods would be part of this. And then this applies to any pod that has a label called details. And then we define an action. In this case, the action is allow. We want to allow access from certain originating pods. And the rules, we need to define the rules from the source. So what is the source of this call that we are going to allow access to the details pod? And then we define the principal. So basically we're saying any pod that has this principal, this is a fully qualified principal. And really this is book info product page. So really we are saying that only service account, any pod that's running under this service account called book info product page, which is right now is only one pod, and that is product page, will be allowed to call into details. So in other words, we are restricting access to details, and we only allow access from the product page because it has a service account called book info dash product page. So let's go ahead and execute this. And sometimes when you apply policies, it may not reflect right away. So you need to be patient and maybe try again and see the results. So we executed that. Let's see if that took effect. Again, we're going to do the same thing we did up here. We're going to, from the ratings, see if we are able to call into details page. So on line 143, let's go ahead and execute that. And we'll see that is not taken effect yet. And now we'll see that we get an RBAC access error denied. So sometimes when you apply the policy, depending how busy the cluster is and how many things are you running, it may take a couple of minutes in order for the policy to take effect, but eventually it will. So now we verify that we are not allowed to call from any pods into details except from product page. So only product page is the only pod which is allowed to access into the details. So far we've been concentrating on the services sides to secure them through a strong authentication using mTLS. We also introduced some authorization who can access for instance, the detail page. Let's switch gear and now concentrate on the UI, because right now no authentication is required, and also anybody can view the application. So we want to change that and add authentication requirements and also add some authorization that only certain people can view the application. So let's take a quick look at the application itself. And this is really a simple books application. So we have the book details and the reviews here. So we're going to change the requirements again. We will require authentication, and also we'll set up some authorization policy. So now let's take a look at the YAML file that has two sections. One is authentication, the top part, and then authorization is below it. So for authentication, we are going to make the end user authenticate themselves. So the policy kind in this case would be request authentication. If you are dealing with service to service, which doesn't require a human being, then we use PeerAuthentication as we saw for mTLS. But for end users, the type would be request authentication. So again, under metadata, we select the name, whatever you want to call it, and the namespace, and that this policy applies to. And then under spec, we need to basically set up the criteria what pods this new policy will apply to. In this case would be app equal product page. So basically it includes all the pods that are involved in the UI part of the application. And if you recall, JWT tokens are used for authentication and authorization. So JWT rules, under which there are two sections. One is issuer, so the name of the issuer that manages the JWT tokens, and also the URL. So this is the URL that Istio will be using to validate the tickets once it is presented by the user to the service. And below that, this is authorization policy. So the kind is authorization policy as we saw before. Again, what namespace it applies to, and also the name of this policy. And under spec, again, we need to select the criteria to what pods this apply to. And again, we app equal to product page. So again, we are dealing with the UI. So we're setting authorization for any pods that has app equal to product page. And the action will be allow. So, and the rules, again, from source and request principles is like before, like when we looked at the service. The only difference here is this is the end user, that will be sending their request. So once the user is authenticated, then their principals or their ID will be passed downstream to the service. So we can capture that, and then we can use that as authorization. So this person will be allowed, whoever has this token will be allowed to log into the application. So let's go ahead and execute that. And then those two policies are created now. Next, we are going to request a JWT token. So we are going to use a test JWT token provider for this example, for this demo. And it doesn't require authentication. So obviously, usually you need to authenticate, the user needs to authenticate. For this testing purposes, this kind of bypasses that. So we're going to curl into that. And then once we get the result back, we're going to echo it. And then we basically use decryption. So we decrypt the messages or the results that come back from base 64. So we decode that, and then we're, so let's go ahead and run that. And this is what we get back. So this is the expiration date, some other information, and then this is the issuer and subject. So that's what the token we got. So on line 164, now we can call the UI and then pass in the token that we just got. So cur minus header, and then authorization bearer, and then we pass in the token and the service, the product page. So let's go ahead and call that. And you can see now this is the raw HTML page from the product page. This concludes our presentation on Istio security, and I hope you found it useful. Even if you are not using Istio, I think this is a technology that you should really look into it, because of the explosion in the growth of microservices and Kubernetes, and you need a way to manage those, both in terms of load balancing, routing them, and also securing them. And even if you're not using, not going to use Istio anytime soon, I hope the discussions on JWT and mTLS was useful, because regardless of technology, they are not really tied, or they're not exclusive used by Istio. You can use, hopefully you found those discussions useful in other applications that you might be using. Thank you, and hope to see you soon.